So this is actually a sort of Fractal talk, a couple of talks bashed together. Loosely based on this is brief. Come on in if you're coming. Not that way. Shut the door. Shut the door. Brought up that bar. Anyway, so brief commercial break. But the thing is, so we wrote this a few years ago based on the experience of sort of the London community, 10 years of arguing in pubs, and a bit of coding.
Longer than 10 years.
Longer than 10, well, it was 10 years when we started this. But we have sort of learned a few things since then, which we're going to talk about. So here, everybody knows this. This is so, everybody knows this now so well, it's become unfashionable. You need to get everybody. Yeah, well, we say that. Everybody claims to know it. Nobody admits to not doing this anymore. So what do we do? Run running tests, make test pass, refactor. Nobody does this bit. How much should it may be possible, but on the whole, in my experience, excessive quality is not the usual problem. There are there are arguments for that, but that's in the general scheme of things. There are some interesting subtleties to this. One which is Kent had a really good line about when he was in college, he was told to separate logical from physical design. No one ever told him how. We think that this is the logical design, statistical design, and it works quite well. And the thing I like about this is that you're actually starting to think what you're doing before you do it. Again, there's another talk about what you tend to get is an awful lot of code written, test and code about this about the same time, which is better than not writing test at all, but it's not this, which is why we call this guided by tests. It's this process of actually doing test analysis. Partly where we're going. So, but this is great. Everybody, we're all doing it. We're all perfect at it. Sometimes it does go wrong. You don't have to read this. This is page 1, page 2, page 3. This is the body of the test. Yeah, they didn't know what it. This is a client of mine. They've since took a long time to clean up this whole mess. There's two ways the test can go wrong. One of which is that you just write the test badly, and it's a reasonable structure. But the other one is that actually this is telling you something about code you're working with. The thing you can't see, it took a while for someone to notice, is that there's a God object in the mark of God. What does this do? This test internal action. I don't know, they didn't know what it meant either. Does the work. And the thing is, these weren't stupid people by any means. They all come from the school, but they kind of taught themselves and got a bit lost. Are there any asserts?
Yeah, expect.
Expectations. Yeah.
It's all set up.
Yeah, it's all set up. And by the way, it inherits from a bunch of stuff as well. There's further stuff. And there's a whole bunch of things about this because it is a messy domain. But like I said, the reason you can tell they weren't stupid is because they could cope with this. In fact, one of the things, if they hadn't been quite so smart, they would have collapsed earlier and maybe fixed the problem. So yeah, test methods. So one, like I said, there's two kinds. One is where the test is not well written, but once you've got the test under control, what we found, what we claimed, is that the sort of things that make code, at least in the object world, because nobody's doing object-oriented, they're all doing functional now. But in the object-oriented world, the sort of things that make code easy to test are the sort of things that are regarded as supposed to be good object practice, like nice sort of coherent units with clean dependencies, all that kind of stuff. And so what we've learned to do is kind of sensitize ourselves to what the tests are trying to tell us. and respond to that on the spot, rather than just pushing through and hoping for the best. So there's another little step in this loop. Back to run the failing test. It's hard to run this test. Ooh, that's a clue. And so, rather than getting sucked into this sort of thing, going, no, this isn't right. I don't know what this test is telling me. It's really hard to run it. I need to do something about the code I'm working with. Let's do something back here. And the thing about this, if you do this when you're in the middle of the loop, then that's a really good time to do a lot of this, because you've got it all loaded in your head. You know what this thing's supposed to do. You know where the boundaries of what you're trying to do are. So this is the moment when you understand the code, to clean it up, to reflect on your understanding, rather than push on and then have to reconstruct that understanding each time you touch the code. And it might be that this is not because you've left the code a mess. It might be that some new requirements has come in and the world has changed. But this is the valid the point at which you go, something's changed. Either I've recognized the problem, or I have to do something different with this code. Now's the change to do this. And this is why we use the term guide. This is when we use the test guide development. I've actually seen it there. Okay. If you pick stuff, they're mostly pictures. So, and I'll try and keep this. I'm going to spin through this a bit quick because of the time. So what I want to talk about first is a couple of examples of this at the sort of unit, the sort of code level. Some common test notes that we see. So here's a common one. Actually, this is where it's going to get a bit difficult. I'll talk you through it. Too many dependencies. So it's very, very common. So here's a bunch of code, and it is a test, and we've got message processor, and this is JMOD, but don't worry about that. But there's a whole bunch of stuff going on. And here's our message processor, and it's got these 5 or 6 dependencies. This is this might or might not be too much, but it's what fits on the slide. But let's pretend that's too many. What does this actually do? Oh yeah, let's find out the slide. I'll move this down a bit. So what does this actually do? We get this unpack, and it packs the raw message based on some counterparty, and then given that unpacked thing, we record that we received it, and then depending on where it's supposed to go, we send it to 1 or 2 different places. There's an awful lot of stuff going on in there, which needs all these different dependencies. And if you kind of look at it, there's a little cluster around here. These two things that go together, they're now never used anywhere else. The unpacker and the counterparty finder. And there's another little cluster around here. Again, these are all used together. And then there's some chunk of behavior in here. And these are just used together. And again, you don't find them anywhere else. But it looks like a little bit of interesting stuff. So perhaps we should recognize it, but actually all these collaborators that we're passing in actually should be clustered together. We can take a piece of this, wrap it up behind some new collaborators, and pass that in, and pull some of the behavior out of this thing, which is getting a bit complicated. And so we end up with this sort of thing, which is, I just unpack the raw message. So I've now got one collaborator here. I do the auditing, bunch of stuff, and then I dispatch it. Where it goes, it's not my problem, it's somebody else's problem. I don't need to know about local and remote and all the rest of it. I just need to send it to somebody. Now you can see this is much more focused on taking messages and doing that stuff and sending it on. Obviously, the number of collaborators just collapses.
Why don't you pass the dependencies in on the method call as opposed to the constructor? If they're only used for that message, for that method.
That's probably a lifecycle thing. So, I mean, the point, even if you pass them, it doesn't, at some level, it doesn't matter where you pass them in. That's a separate issue. That's more to do with lifecycle and scope, if you like. But if you're still passing them in, you're still collaborating with all this stuff, and actually, it's even worse perhaps if you're passing 2 or 3 things in that you then bolt together inside, and then, or use because that kind of implies that you should pass in something that does all that work. Why are you doing it here instead of the place where you're getting it from? So, yeah. So that's one sort of example. Here's another one. There's too many assertions in the test. So it's a bit obscure. This is JMOC syntax, but it says, so I've got this thing, this claims processor, I'm going to do something with this stuff. And in JMOC syntax, these are all hard expectations. It insists that I'm going to find out whether the first part's ready. I'm going to insist that I get the adjudicator exactly once. I'm going to insist that I do this find case, and I'm going to insist that the third party proceeds with the case. And that must all happen. This test can pass. And I see an awful lot of code that uses this kind of stuff. That we can get this, particularly for a certain generation of code, where all the interactions are strictly insisted on. But there's an interesting difference, which is that there's only one of these that changes the world outside this object, which is this one. The third party will proceed with the case. The rest are all queries. And I can call them once, I can call them 7 times, it doesn't really matter. If you like, those are set up, and this is the actual thing. If you did design by contract at college, these are preconditions, this is a post-condition. So why don't we say that? Actually, this is the code. And again, you can see it's a bit lumpy. If the first part is ready, do some stuff, otherwise do some other stuff. So why don't we just soften what we set, how we're setting up code? And we allow, in our terminology, we allow stuff to happen. It's like it's a stub effectively, because that's set up. It's not what we really care about. Now we can look at the test code. This is the one that matters. This is what we care. This is what we have to insist on. And the thing is, again, when we look at this, so once you sort of start focusing on what really matters, you start to think about, well, I've got all these queries going on. Is that quite right? And you can see that this is imbalanced. Finding aesthetics actually are often a clue as to what belongs where. Maybe we should just move behavior around, take all those collaborators and push them out, and then the tests, which I've written up, get much simpler. So now we have just a simple switch, and everything else being pushed out of this object. All that complexity is pushed out in this object to another object, and it's a bit more balanced. So the third one in this series, are we okay? I'm pushing on quite fast. Can you hear me at the back as well? Speak kind of please. So again, this is particularly something you see in the dynamic languages and the virtual machine languages. But got this test right, and it involves some clever thing with a singleton or some bit of code that I can't change. So I'm going to use aspects. That'd be really cool. In fact, coming after the talk, I'm looking at the solution space, not the problem space. It's a really cool thing. And that's a clue. So let's look at an example of that. Here's the test. It says reject the requests that are not within the same day. Set requests, then we move to the next day, and then it comes out. And here's my date, so I can tell it's the next day. How do I test that? Do I wait till tomorrow? Do I do some clever reflector magic? Not really keen on that. Oh, in fact, there it is. So, because the problem with this is under the covers, that call system get time, whatever, which is a singleton that changes every time. What to do about that? So a very common practice is to say, put a clock object in, or something like a clock. It's not a reasonable sort of starting point, which is, so then I can set the date. control time as we step through. And now I get the data from the clock, not from the system. Okay, that's pretty straightforward. But the interesting thing about this is that, you know, this is sort of good for triggering, making you think about things. Because one of the things you can see is that in this code is that there's a shift in language. You get a lot of this. So there's stuff about dates and is it today or tomorrow or whatever. And then there's the actual handling of the request. There's a sudden shift in language. And clocks and things. And maybe that's a clue. Maybe what I actually want to do is introduce the concept that wraps that all up. And so introducing like an expiry checker. So let's take that decision, push it somewhere else. Maybe also take a request. I don't know. And now this is much easier to test. And the language is like consistent. I'm now in the language of handling messages rather than today and tomorrow and the rest of it. And maybe this is overkill, but it's really nice when it turns out they want to put your server in a different time zone. You've got everything ready, everything's localized, and you've got nice, clean separation of concerns. And again, this thing about looking for languages, I'll come back to that. So here's my favorite example. This is some shit for what I stole off the internet. That's on video. I didn't steal it, I borrowed it. There's a couple of interesting things about this. One is that it's a public record. This is not for the benefit of the captain when he retires doing like memoirs. This is a public record for the purpose of running the ship. And the other thing is it's got a very clear structure to it. Again, it's not just arbitrary scriptings. It serves a purpose. And it has some formalities to the structure. So here's another log. Here's a log. Jump switch up over. If it's a full, if it's not full moon, I need to. But what's this? This is a singleton, right? And I know there are clever things you can do to go around and depend on. But that's the right pain and unpleasant stuff. And again, with switch in language and the point thing about logs, particularly things like error logs, is they're part of your user interface. When they go to production, whether they use it like you or some system administrator or whatever, and I need to know whether it has to be this or not. And I've seen so many systems that just kind of grow and grow, where I don't know if I can change the source message. Because where that matters is 4 organizational levels away. And I've got nowhere to sort of exercise that. Oh yeah, and by the way, now we want to move this to desktop with code. Where's the log go? So again, why don't we say what we meant to say? Which is, I'm going to report that I need another incantation. Let somebody else take care of that. And I'll come back to that in the second section, with the second bullet on the second. So at the moment, this is all about, so this is the, people know about the ports and adapters. So this is our nice clean model, very clean in there. And outside is the real world full of nasty things like people and databases and stuff. How do you get from one to the other? You define ports to the outside world, which define what you need in your terms, and little adapters as thin as possible to get you to the outside world. And in here, this is where most textbook education goes around. It's this nice clean world where everything's under control. But that's not where we live. Not where we all live. There's another level outside that. In our world, that's our end-to-end test, part of the library. And we can take the same principle, which is that the test can tell us something about what we're working on. Let's jump right in first. And if we think about coming in at this level, this is sort of a complete sort of black box testing. How do we test? What do we need to be able to test a system at this level? So these are the sort of things that you might need to do. well, you need to know what the system's doing, at least the various points. It doesn't know when to stop doing it. The big problem with a lot of larger scale tests is it's hard to tell when things actually happen. I'd like to know what's going wrong, preferably as soon as possible. I'd really like to know why it's gone wrong. There's nothing worse than the computer says no. You then dropped into 3 days of debugging and tracing and hope you can get this thing to work. And then finally restore it to a good state so that you can get back again. If something fails, you can get on with the next one. And the point being is that these sort of things are often the same sort of things you need to know in production. And you get, if you do it naively, you get this sort of problem. Like, hands up who's got flickering tests. Right. Because everybody else is not testing. That's where you get, you've got your system and you've got build monitors and all the rest of it. And there's a bit that goes red periodically. And that's all right, we'll catch it on the next time through. That's just the a bit slow. And the problem with that is you never quite know when the thing actually works. Because even if it goes green, you're not quite sure. And you lose trust. And more to the point, you're missing a clue about something. Similarly, you can get false positives, you get race conditions, and you can get false positives. So what you then do is put lots of pauses in. So the test now takes 3 days to run, and everybody ignores them. And so then you get clever and clever and clever, and you sort of keep the pauses down, you stick them in there everywhere, and you get messy tests. You can't see what the hell's going on because they put your netbook in and then half your test break because you've got 1,000 different sleep messages, 1,000 different sleep calls. So these are okay as interim positions, but they don't help you very much. So let's look at some sort of some of the sort of things you might get from sort of this level of testing and what the feedback you might get from that. So here is eventual corporate enterprise, yada yada yada. Actually, it's not just corporate. So I've got my perfect system here, it's beautiful. And then over here is the strategic system, generally written in America in my experience. And who knows? We've got this weird protocol that they've written to be efficient. But to be helpful, they give you this API. The thing that you just plug in your application, it's great. The trouble is, it's written to be completely locked down, so you can't test against it. And by the way, it leaks memory. So how do you actually run test cases? Oh, and by the way, sometimes this costs money to run. Sometimes you touch it. So you might not want to do that. 20,000 times a day. So it might be bad, but if you think about all these, now we're all in the cloud, touching some web service or something, that could still be true. So one technique is a level of indirection, and in domain driven, this is called a anti-corruption anti-gap, or a protocol converter. That might be called a syndicator. But what we do is we do pitfalls and adapters. Is your port, which is a simple, in fact, the port kind of goes up to here. Is your simple API, just what we need, not what they provided. Nice simple protocol, probably HTTP, that's very clever. And then that hides all that stuff. And the reason you might want to do this is you can test it. You can have a nice fake, just pop a web server in your test, system test, and then you can check out those. That begs the question, how do you know that Simplicator works? You might write a smaller number of tests that go from this end through. Maybe touch some of the softer parts just to make sure it all comes together. But you do get some nice features from this. One of which is, so you're dealing with this API, is that you now have a place where you can test upcoming changes. So they've got new releases coming through. You can pre-test separately before you take on whatever it is that they want to give you. You can run this against production UAT, all that kind of stuff, see if it's still working. In fact, the team that did this, their build monitor turned out to be a better predictor or a better reporter of what was happening to UAT than the official monitoring tools. People started to look at their build monitor rather than the official messages, the official monitoring messages. And then the other thing it turned out was that actually, I think there's a separate picture somewhere, but actually in production this is just HTTP, right? Well, you can put standard web cache in there and also completely cut sort of dependency on the external system and with nice tuning and everything for free. You don't have to do that. So a nice little thing is it's a point, sticking a point in an extra sort of point of access. It sort of opens up new possibilities. So let's go back to the logs. Let's go back to the real world. So here's some more logging code. Hands up who's never seen anything like this. Right. And there's lots of log horror stories. Systems where where the logs were so big that they got rolled off the disk. And when the bug reports came in 12 days later, the logs were all gone. So they've been equally effective if they hadn't bothered. A chap called Martin Thompson does high performance stuff. He says a lot of the systems he looks at, actually the real performance killer is logging. At least the standard log libraries. They could go a lot faster again if they turn the log rate. There's other things you need to do. But what are the sort of symptoms of this? One is it's a mess. So again, you've got this mix of terminology. And always look for the language. You've got this change in terminology. There's stuff about cookies and things and web pages, and then there's stuff about Java logging. We're not talking about one thing, we're talking about two things here. Why is this? This is influencing both this error. Why? I don't know. Is this actually an error? You know what this means? Log an error, rethrow. This means I'm in terrible hurry. Project manager's beat me over the head. I'll log it and carry on. I don't know what this means. You know what happens next level up? And the next level up. So you try to scrape the logs, you've got half a dozen of these, exactly the same thing. And we don't even know it's an error. We might be a perfectly valid condition that we're prepared to deal with upstairs. Oh yeah, the URL's in the middle, the URL's at the end. Try scraping that. Why do you even bother with debug? Why don't we just have the code and then we can work with all this kind of stuff? And it just goes on and on and on. And all of this is about not expressing what you mean, not taking time to think about what you actually want to say. So why don't we pop in a new collaborator, we'll call them on whichever, I think there's a better name. What do we really care about? We want to know that we received a request and that we've loaded the page. The rest of it just disappears. And now we're sort of talking in terms of, at least in terms of the customer, in this case, which is us, so we talk in terms of the problem, not the solution. And how's this implemented? It's not Argo, okay. Somebody has a problem. And once you've kind of broken this thing, you can start to do interesting things. So once you defer the delegated decision about how that's actually implemented, which might be a lot, or it might not, that opens up new possibilities. And in particular, here's our monitor. This particular system is sitting on a reliable message bus. So why don't we just pop it on the bus? And then you can do with it what you like. And you might have real-time monitoring. You might actually do some logging with particular messages. You can select them out. If you're really clever, you might do some stuff feeding, throttle queues if it's getting busy. But that opens up the possibility that wasn't available if you just push the implementation. And you get some structure to the events that get sent around.
I love the picture of the toilet roll.
Yes.
My friend Johannes, when he sees code with log, he has a phrase for that. He says it stinks of fear.
exactly true. Right. Oh yeah, so. Here's a model that we sort of often thought, when we're looking at this is that what we want is to have our test and then have the system tell us what we need to know. And then, or tell anybody who's interested in what we need to know. One of those candidates for listening to the system is a test, and we can use that. And turns out to be useful in production. So here's an example where find some requests, a bunch of stuff happens, and you need to know when it's finished. Well, let's have the system tell us, report when it's finished that particular request. And we can stick a little ID on it, so we know what's going on. And that makes the test much easier to write, rather than just report it away. Actually, this is useful in production, because you want to bring this thing down in production, but you don't want to. You want to wait till everything's clean. So what you do is you turn off the tap, and when you get all the finished IDs, you know the thing's safe, and you shut it down. So again, the thing you stick into production turns out to be useful. A thing you stick into testing, perhaps, turns out to be useful in production. So here's a thing that's quite common, is you take your service, you stick a schedule in it. Every 10 minutes there's a clean up, end of day there's a big clean up, whatever. Go and test that. Absolute nightmare. That's not music, right? Absolute nightmare. You end up sort of shutting it down, fiddling with the configuration, putting it back up. Horrible. What we want is to be this sort of situation where here's our testing bit, our system bit, is that we can fire something to the thing, and it spins around a bit, and then it stabilizes, and then we can see what's going on. And we want that sort of to be able to control that triggering activity. So let's pull the schedule out, and we get set the service, and request wake ups, and get told when things happen. And that's, now you've got that sort of behavior isolated down, and you can control it. You can test it rigorously so you make sure your schedule works. But now everything to do with time comes in from outside. And you can completely rework your tests. So here's your fake scheduler, here are your fake simplicators, and now the whole world, all the messy stuff that you do for exercising and stuff is now under control of the test. You can see what's going on. And that means that these tests can run really quickly. We've got better control of what's going on. It's not, yes, it's not the whole thing, but in practice, for an awful lot of what you do, if you want to see what the behavior of the system is, this is quite an effective way of doing that. So what we're doing is we're taking these sort of completely black box tests. We still need some of these to make sure the whole thing hangs together. But we can get an awful lot of mileage by coming in like through reports rather than through the outside external system. So that was the point. Okay. Hard to write a test, refactor. So that test the system turns out to be the sort of thing you need to support the system. And one way to look at this, if you think about quality, there's sort of internal quality and external quality. External quality is, is it to spec, does it do what it's supposed to do? Does it go fast enough? All that kind of stuff. And internal quality is this code we can live with. We need to make a change, can we do it without pain and misery and the smell of fear and all the rest of it, and reasonably predictably. So where do we get feedback? We get feedback on internal quality from unit tests on the whole, various other things. But that will tell us whether the code is reasonably well structured. But it won't tell us whether it does, to some extent, it won't tell us whether it does the right thing. We get feedback on external quality from our system tests, and then there's a bit of little sort of integration things. And so they sort of serving different purposes. And the thing about the system test is also, one of the points about it is that when you're trying to write a system test, the thing you need to know to make the assertion, whatever it is you want to say, is a clue about what you need to know about what's going on in the system. That's the feedback loop. Is if I need to get this access to this particular data structure for the test, perhaps that's important. That's what I need for the rest of my life. So unit test keeps the system easy to modify. System test, in theory, can keep the system easy to support. Which leaves us 7 minutes. Any thoughts?
These simplicators that you write, a lot of the time the API will be returning different values depending on what you're, I don't know, say you've got an API that's after a banking system or something, and it's returning IDs or whether you've got enough money in your account, for example. So you have different test scenarios and with different accounts perhaps, but do you write your simplicators to handle different scenarios? Is that the kind of thing you do?
No, so just be clear about that. So they're not simulators.
Mm.
They're stubs. So what we do is within a test. Oh, sorry, you mean the ones that go in the test or the...
Yes, yeah.
Sorry, let's draw this picture. This picture.
Mm-hmm.
So there's the production simplicator, which is just a bridge. Yeah. There's the test simplicator, which is a fake.
I see.
Yeah. And so you fill it with the values. You hard code the values in the test. You fill it with the values that are relevant to that test.
Mm-hmm.
You're not trying to write another system.
I got you.
There is another school of thought about writing simulators. That's a separate issue. That make sense?
Sort of.
Anybody else?
Your monitor. You when you showed your monitor
Yeah.
to replace all the logging complexity from Nano.
Yeah.
Maybe the previous slide, I think, as well. So you got methods, request, receive, loaded page. So I suppose that the monitor's going to have lots of methods
Yeah.
that are domain specific.
Right. So two things. There's two ways of doing this. One is that you have one method and you pass structured objects into it, event objects. The other one is what I tend to find is I have a sort of monitor per module. Not a sort of package, but not a Java package, but some related bunch of behavior. You have one of those. And so rather than probably won't have one for the entire system. And that's actually quite good because when you start to see the commonality, you start to say, actually I've got one of these messages already, why don't I use the same one? Rather than typing in some string or something else like it. So yeah, there is a scope thing there. But often it's quite valuable to help you see what's shared around the system.
I just wonder what you meant by external authority. Does it mean that everything works together?
What's externally visible? So does it actually have the right functionality? Does it actually work? And that might include, does it go fast enough? Does it scale? Does it fail properly? And all that kind of stuff. Anything that the user or the client of the system cares about. But the client of the system doesn't necessarily care. In theory, doesn't care about what the quality of the code. That's a sort of separate issue.
The anti-corruption layers,
Yeah.
would you put those in, sort of as a rule of thumb, would you put those in anywhere where you've got sort of third-party dependency or maybe an external component that isn't really part of the...
Again, there are multiple levels of that. So, in that particular case, because you're dealing with this horrible third-party system, so which is just too hard to work with, so you stick this thing in the middle as a protection. But you might do that within your code as well. Common sort of practice is I have my sort of port layer, and then there's an implementation behind behind that, but it might not be in a separate process. It might just be.
It's just like logically, it's a separate area, so you don't, you want to be able to kind of plug them in and not place them.
Or at least you want to have that localized. That's more about information hiding. This is what I need from the world. You give it to me. I don't care how you do it. There's a little bit that says this is how we do it. And separating those two issues. And so what you want to avoid is that stuff about databases and messaging, whatever, leaks all the way, leaks into your code.
Is there a point where you'd say there's too many of them? So I mean, would you just like liberally use more, by default use them?
Well, the thing is, there's not like a hard line here, because that's true for inside your system as well. I've got this sort of module over here that depends on this particular service, which I'm also providing in my code. But I want to test that.
That's not what you're testing in that particular instance, for example. So
yeah, and the testing is a clue. So the sort of good sort of code structure says that's not relevant here. Define the service and let someone else take care of that. Where someone else might be me or somebody else. So I think it's a general principle. We just apply it to different scales. It's less common to have people think about applying it at the system scale.
Yeah, so where you were using ports and adapters
Yeah.
to, for example, go to the database and the like, I mean, is an example of that like a repository pattern, or is this a different kind of approach to that? So we saw another talk yesterday where I was talking about a similar thing about APIs, and it just wasn't clear to me. You're talking about having some kind of strongly typed, go and get me this, and it returns back objects rather than some form of SQL or at the implementation level. What does that actually mean?
But it might mean that. So the reason I'm going to go back up a little bit is, so we have this horror of calling things repository, manager, whatever, after the pattern rather than things. So I get a bit nervous about that because it turns into something that's described in terms of implementation, not in terms of purpose.
Right.
But yeah, so I mean, a good example, rather than conventional examples, rather than talking about a customer repository, the better thing is to talk about an address book. Or service is the other one. Rather than talking about customer service, you've got an address book. So, and that perhaps in that case is you talk to the address book, you say, give me some address, and that's actually a repository that goes to the database. There may be another level, but at that level. That helps. So, I think we might. One last question, anyone?
I asked about debug because I'm one of the worst. I'm probably full of big errors. My code is full of debugging, and we do have a system that people compile it out.
Yeah.
For runtime. But I mean, is that this obviously isn't debugging. This is kind of more what we call summary or detail type logging. I mean, is there a similar pattern to that you can use to the debug information you only want to turn on in certain cases?
No, I think the one thing we realised when we were writing, or I realised when we were writing this up, is that so one thing about this, at least is good, is to distinguish between debugging, which is internal, and proper logging, which is external. So to be clear about that difference, that's sort of, because a lot of code, like the other example, is not really very clear what you want. Systemics, I think you have to find your own way. But the other thing is a lot of languages you can attach stuff. If you aren't actually debugging, you can attach stuff dynamically. There's a whole bunch of things you can do without actually changing code. But again, I think perhaps the main thing is to be very clear about what's internal and what's external, and that if it's external, it's properly supported, and you know what it does. I think I see a lot of this stuff. It's a very common way.
Yeah, that is what my code.
I think an underlying pattern here might be that you see that, so you copy it, but at the two extremes you can imagine, you do that, and then when you get something that you have to debug, you look at the logs and you find there's so much logging it doesn't actually help you.
Okay.
So this is put on before you know what's useful. The
Yeah.
alternative is you don't put any logging. And when you get a situation where logging would be helpful when you're debugging, you know exactly what you need, and that gives you the clue about what kind of logging you need to do.
Although you get chicken and egg there because, you know, well, stuff fails, you have no idea what's happening. So I had, I've written under
I
log
did say
6.
so extremes.
Yeah. Good. Shall we? I think we'll break.
That's it.
Thank you very much.
Thank you, everybody.